Hi, and welcome to my video explanation of the lab entitled Make a Concentration Series of Solutions. As you can see, I have my 5 solutions in a dry erase board that explains some of my calculations here. And I decided to use measuring cups as I figured that would be the easiest way to read the amount of solution water that I was adding to each of my measuring cups. So I started out creating my mother solution, as you can see at the far left. And I did that by dumping a packet of Kool-Aid into the container. The mass of the Kool-Aid was 4.5 grams, and you can see that because it says at the bottom of the packet, 4.5 grams. The next step I did was finding out the molar mass of sucrose or sugar, which is C12, H22, and O11. So I took carbon 12.01 times 12 plus hydrogen 1.01 times 22 plus oxygen 16 times 11, and the sum of those was 342.34 grams per mole. The next step was to find the mole of the solid I just created. So I took the mass of the Kool-Aid, 4.5 grams, times 1 mole over 342.34 grams per mole. The answer I came up with was 0.013 mole. From there, I added 150 milliliters of water to my mother's solution, so at that point I have the water and I have the Kool-Aid mix. The next step was to find the molarity, so I took 0.013 mole, and I divided that by 150 milliliters, but I had to convert the milliliters to liters, so it was 0.150 liters. And the answer to that was 0.086 molarity for my mother solution. So step 1 was I transferred 25 milliliters from my mother solution into container 1, and I added 150 milliliters of water. The dilution equation for that was 0.086, so the molarity of my mother's solution, times 25 milliliters, the amount that I transferred from the mother's solution to container number 1. And then I divided that actually by 175. That's the total amount of both solution and water that I now have in my container. And the molarity there was 0.012. Now that's the molarity for number 1, solution number 1. I then transferred 50 milliliters from solution number 1 into solution number 2, and I added 150 milliliters of water for a total of 200 milliliters of water. The dilution equation for that was 0.012 times 50 milliliters divided by 200 milliliters, and the molarity I got was 0.003, as you can see there at the bottom. The next step I had was to transfer 75 milliliters from solution number 2 into solution number 3. And then I added 100 milliliters of water. The dilution equation for that was 0.003, or the molarity from number 2, times 75 milliliters, which was the amount that I transferred from 2 to 3, divided by 175 milliliters, which was the total amount of water that I have in container number 3. And the molarity of that was 0.001. The last step that I took was I transferred 100 milliliters from solution number 3, and then I added 200 milliliters of water for a total of 300 milliliters of water. The equation for that one is 0.001, so the molarity from number 3, times 100 milliliters divided by 300 milliliters, because that's the total amount of water in solution that I have. The molarity I got there was 0.0003. Now, I know that the goal here was to create a molarity of 0.00001, which is parts per million. What I figured would happen is if I continued to add more water, that would continue to dilute my solution even further, and I'm not exactly sure how many steps it would take, but anywhere between 5 to 7 steps of adding water. I think almost 1,000 milliliters of water would get me close to that parts per million. So that concludes my lab for this evening. Thank you so much for watching. Bye-bye.